These are the frequently asked questions for Algebra 2 for section 11.8, day 2, starting with number 12. It says a calculator contains 4 batteries. With normal use, each battery has a 90% chance of lasting for 1 year. What is the probability that all 4 batteries will last a year? So we start with our combinations to count up how many possible ways there are to do this. So all 4 batteries will last a year. Well, that means out of the 4, we want all 4 to last. And the probability that they're going to last is 90%. So that's going to happen 4 times. But if the probability they're going to last is 90%, that means the probability that they're going to fail or not last is 10%. And because all 4 of them happen to last for the whole year, none of them were failures. So you would go ahead and punch that one into your calculator, and just to save time here, so that I'm not spending the whole time punching these in, that's about 65.61%. So again, just carefully punch those in. Use Pascal's triangle for this if you want to too. You know that we know that 4C4 it's 1. And so technically, because 0.10 to the 0 power is also 1, you really would just need to punch in 0.9 to the 4th power to get that. All right, number 15 says expand each binomial. So I want to use the ABCs of binomial expansion, and I see my A value will be 3x, and my B value will be 2y. So I start by taking my A's and doing those high to low. So 3x to the 5th, because that's the highest power we have, 3x to the 4th, 3x to the 3rd, remember to leave yourself some space to work here, 3x squared, 3x to the 1st, and 3x to the 0 power. Remember Blaise Pascal, computer guy, we are going to use the zeros here. And then we go after the b's, and the b's are low to high. So 2y to the 0, 2y to the 1st, 2y to the 2nd, 2y to the 3rd, 2y to the 4th, and 2y to the 5th. And now, because we know about Pascal's triangle, we have a choice. We know the c's go low to high, but we also know Pascal's triangle, and we could use row 5 to get all of those numbers that we need in front that are going to help us get the coefficients right. So row 5 of Pascal's triangle is 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. And then the next thing we do is check for the sign, and in this one we have addition. So that means all of the signs are going to be addition. And then we would carefully grab a calculator and just start figuring out what is everything that we have for each term. So in this one, I have the 1 out in front, and then 3 to the 5th is going to be 243, so 243x to the 5th. And then anything to the 0 power is a 1. So our first term there is 243x to the 5th. Plus, well, new box. This time we'll have 5. 3 to the 4th is 81, so 81x to the 4th. 2y to the 1st is 2y. So we'll have 5 times 2 is 10. 10 times 81 is 810. X to the 4th, y. And then we go on to the next term, where we have 10. 3 to the 3rd is 27, x to the 3rd. And then 2y squared, that quantity will be 4y squared. So we need 10 times 27, which is 270, and then we need that times 4. And that will be 1080 x to the 3rd, y squared. Plus, move on to the next term. Here we have 10. 3x, the quantity squared, is 9x squared. 2y, the quantity cubed, will be 8y cubed. So we really have 10 times 72, which would be 720 x squared y to the third, plus, next term, 5, 3x to the first is 3x, 2y to the fourth is 16y to the fourth. So we really just need a 15 times 16 here, which is 240 xy to the fourth, plus, last term, a 1 in front, 3x to the 0 power is also going to be a 1, and then we need 2 to the fifth y to the fifth, which will be 32y to the fifth. So 1 times 32y to the fifth is 32y to the fifth. And that one is completed. So just be careful with your ABCs. Again, you can put the C's in there if you want to, or you can go ahead and use Pascal's triangle. Pascal's triangle is quite a bit easier. All right, now we're looking for number 17. And number 17 says we want the second term of 2g plus 2h to the seventh. So we don't want them all. So we start thinking, okay, if this were the second term, we can start with our c's that would be out in front. For the second term, well, remember the first one would be choose 0, so the second one is going to be choose 1 from those 7. And then we have to think about the fact that our c's always go along with our b's. So our b here was 2h. So that 2h is going to have to be to the first power, because these two have to match for the b's and the c's. But then our a value, which would be 2g, because this is a plus b to the n, well, that has to make up the difference. So if we have a 1 in this position and a 7 over here, that means that we need that 2g to the 6th power. So now at this point, we need 7, choose 1, which hopefully, you're looking at it right now thinking, well, what I know about Pascal's triangle, I know that's going to be 7. But if you need to, you can always punch that in. That's the reason Pascal's triangle is so helpful when you're learning how to do probability. So we have 7, and then we need 2 to the 6th power, which happens to be 64g to the 6th. And then we need 2 to the 1st, which is just 2, and then h to the 1st is h. So now we find we need 7 times 64 times 2 in order to get the coefficient, and that will be 896 g to the 6th h. So that is the second term that we would have in that expansion without having to do the whole thing. And that's exactly what we want to be able to do here. Not have to do the whole thing, just do the term that they want. Save some time. Oops. I wanted to do number 18 as well. So 18, we want the 5th term of x minus y to the 5th. So I start thinking about my c's, and I realize, well, I'm going to have a 5 here. But remember, it's going to be 0, 1, 2, 3, 4. So it will actually be a 4 in this position to figure out what I need for my C's and my B's. So now my B value, normally I would just put a Y, but because I just want this term, there's 2 ways I can figure out whether or not this is positive or negative. I can sit and tell myself, okay, that first term of a 0 will be positive, then using the 1 will give me negative, using the 2 will give me positive, using the 3 will give me negative, and then using the 4 will give me a positive. Or I can simply say, you know what, I'm going to treat this like A plus B, and I'm going to use a negative Y for B when I just want one term. So that's going to be to the 4th power. I already knew it was going to be positive anyway because of what I just talked you through, but that verifies it. And then my x, which is my A term, is going to need to be to the 1st power because these 2 powers always have to add up to n, our total. So now we have 5 choose 4, and again, it very well could be that at this point you're using Pascal's to find that or thinking about symmetry there. But you get 5. And then we have x to the 1st, y to the 4th. So a couple of different ways to work through whether or not you believe it should be positive or negative. You can either just kind of go through it in your head about the position that it'll be in, or you can go ahead and use that B value as a negative number, and the power will indicate whether or not it's positive or negative. Then number 25 says a survey has found that 80% of respondents eat corn on the cob in circles rather than from side to side. Assume that this sample accurately represents the population. What is the probability that out of 5 people you know, at least 2 of them eat corn on the cob in circles? Well, that means out of the 5 people, at least 2 of them, well, 2 of them counts as at least 2 of them. So we'll have 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. And that's because of these 2 little words that we really learn to hate in probability. At least. That means you have to do more than one. And then you go through and you say, all right, 80%, 2 people are going to do that, so 20% of the people are not, and I need a total of 5. So that'll give me what I have. I need my success to be 80% for two of these, and then I need my failure, which would be the 20%, for the other 3. And then this one would be 80% 3 times and 20% twice. This one would be 80% 4 times and 20% once. And this one would be 80% all 5 times and no failures. And what you would need to do, because these things cannot happen at the same time, is you're going to go ahead and find each one. And then this is an or situation. It's one or the other. So you're going to take those results and you're going to add them together. And let me look up what you should get when you're done. Obviously, I don't want to spend time punching this in for you. This should come out to 0.99328 when you have done that. Now, the other way to do this one would be to say, you know what? I notice I have the 2, the 3, the 4, and the 5 here. So I could take 100% and I could subtract 5 choose 0 and 5 choose 1. Both of those ways will achieve what you want it to achieve. Then number 28 says we have a fruit company that guarantees 90% of the pineapples it ships will ripen within 4 days of delivery. Find each probability for a case containing 12 pineapples. So in number 28 it says at least, and again those are those dreaded words right there, at least 10 are ripe within 4 days. So out of the 12, it could be 10 of them, it could be 11 of them, or it could be all 12. And they guarantee 90% of the time that that's going to happen. So that's a success. There will be 10 successes here, which means the failure rate, which is 10%, will happen twice because there will be 10 successes and 2 failures for a total of 12. Then for the second one, we will have 11 successes, which means 1 failure. And then for 12 choose 12, all 12 of those would be successes, and we wouldn't have any failures. So you're going to go ahead and calculate these 3 again. And then each one of these, you have to think, can these things happen at one time? You know, can exactly 10 of them happen when exactly 11 of them are happening? And the answer to that is no. You count it once and that's what it is. So when you get done, you add this together since this is an OR situation. And for number 28, that should come out to approximately 0.8891. And that'll help you figure out whether or not you're punching those in correctly. And that is it.